And then the result is, improved normalization age, the brain age. And but the thing is, it's not perfect. If you see this, perilegional area, then there's some, unsatisfactory region, and studies later, they found that cost function masking looks like not working. So this is one evaluation study done by Cranion et al. And left panel shows normalization results. This is normalization evaluation outcome metric. Root means square distance. So larger, worse, and smaller, the better. And they used SPM normalization algorithms to compare the results without and with cost function masking, and it's pretty much the same. So that actually kind of devastated a lot of people, because for nearly a decade, people believed that cost function masking works, but actually it didn't. So all the time, you drew your lesion and run this extra step. So that was pretty bad. But so then, what's the alternative? So one alternative that, when I explained this problem to Pixel Lab at Penn, they came up with, actually Brian Avant, he came up with this method, constrained cost function masking, and it intended to improve traditional cost function masking by imposing more constraint within and around the lesion area. So these are the steps. This is original brain. First, you label it. So lesion drawing is something you cannot get away with right now. So you draw this lesion mask, and then instead of totally excluding this lesion area from calculating this cost function, you use perilegional values to fill up the missing velocity field within the lesion. So what you get is this smooth Jacobian determinant field change from the perilegional area to within lesion area. So it's similar to traditional cost function masking, but it can deal with larger lesion and bilateral lesions, which are more challenge to traditional cost function masking lesion. So if the lesion gets larger or bilateral, then it was known that traditional cost function masking didn't work well. So after normalization, you can see that the lesion area is pretty preserved, but the other area, the diffusely affected area, they went through quite large deformation normalization. So this is quick evaluation, qualitative evaluation of that method. This is the original brain with big bilateral frontal lesion, and this is symmetric normalization without any constrained cost function masking applied. And as you can see, it totally, made it disappear, made the lesion disappear. And this is symmetric normalization with constrained cost function masking. It preserves the lesion area. So this is the template. So this is probably what you should use for VLSM for accurate representation of lesion extent. And this is the last scheme, a clever scheme that I want to mention. It is called Ingeomorphic normalization. I never looked it up, the word Ingeomorphic, but the idea is very simple. So this is for largely lateralized lesion. So if you have your lesions in all of your subjects on the left side or right side or something, then you can use the normalization information or deformation information of the other side, the intact side, the side without lesion, and then use the same information and apply it to that lesion side. So this is the process, but I don't want to delve into it. So this is my last slide. I put this slide up because it looks like almost every option we have right now has to draw lesions. So drawing lesion is an important step that we cannot omit right now. But people are trying to make this step more convenient by developing automatic algorithms of detecting focal lesions. But I heard that it's not that going well. The reason, the typical challenge is that many automatic detection algorithm requires kind of registration before detecting the lesion. So it's a kind of tautological problem right there. So we need to define lesion to improve registration, but to define lesion we need we need a registration. So it's circular challenge. So that's pretty much it. And if you have any questions.
I just want to mention that there is now an SPM toolbox. I think it's called ALI for automatic lesion identification. It does it tries to do lesion segmentation as a separate tissue class. And supposedly it works well enough that you look at it and you're pretty happy with it, but not well enough that you don't have to touch it up afterwards.
Right. So so there's this new thing, ALI. SPM, a toolbox which approaches this automatic lesion detection problem as a segmentation issue, and it looks like actually oh, I should not mention it, but they claim that it works well, so we should definitely check out.
Guys, I want to tell you that it's 5:15, so we're already 15 minutes over the session, and Olu, was due to talk today, hasn't gotten a chance to do it. So, so I want to give you two options. Remember, we had pushed the last session to the 16th, right, leaving next week free. So the option is to continue with that schedule and try to fit everything, if you guys think it's possible, into that last session. We could go one further beyond that, or we could, whoever could meet, is able to meet next week, could meet next week to finish up this part of the course, and then the 16th would be Dan's last part. So, any feelings about this? Any constraints on, particularly those of you who travel here?
How many people can't be here next week?
Yeah, how many? I can't. One or two other people, I think, emailed me about it. Otherwise, people can come next week. So then I suggest you do that.
Do we want to come next week? Because I don't know if I have enough. I guess I can expand it to take up the whole section, the whole hour. Probably.
Well, we can do that. We can have questions. I mean, I'm sure.
Yeah,
well, we could do it from 4 to 5. Is it hard to get here at 3:30? I mean, is that, or do people have difficulty? I mean, what I think is that you might want to, you know, do your piece and then use the last part of it to just sort of review issues that I'm sure have come up and people have been too intimidated to talk about, to raise questions. I can't be the only one that has stupid questions. So, so you know, we could certainly do that, or make it shorter and then leave the fourth session as it is for the 16th.
I would say we start at 3:30. If we get done early, then that's fine.
Yeah.
Mm-hmm.
Yeah.
Yeah. Okay, so let's do that. 3:30 next week. We'll send out yet another correction reminder. Well, thank you so much. This was great.